over the last few years. um, my agenda here is pretty simple. I'm going to talk a little bit about what the current state of the art of Pro AV, AV over IP is, and then I'm going to go into IPMX, and then we'll talk a little bit about what it means for Pro AV. Very briefly, right now in Pro AV, the AV over IP market really has matured. I think safe to say that in the past maybe 2 or 3 years, we have really seen the emergence of, or maybe even more than that actually, we've seen the emergence of quite a few different options in AV over IP that give us great quality, low latency, and the kind of stability and features that customers are really looking for. Any one of these options here is a great fit for certain applications, and you might pick one over the other depending on if you're, if you're mostly interested in perfect quality and you've got lots of network bandwidth, or maybe you're more working on like live production. That might be another option that you might pick. The big dividing line here, though, is that on the, sort of on the left, you've got a collection of kind of single source chips or libraries that give multi-vendor interoperability. And by that, we mean that, manufacturer A's device can communicate with manufacturer B's device, but there's really just one chip or one software library implementation. So it's not interoperable in that sense, but it is interoperable in that multiple vendors can have products that work together. And on the right side, you have more of your proprietary ecosystems where you've got a vendor that's got a wide array of products to meet a lot of different needs. And when you're buying their products, you're getting, their unique features, their special sauce, but it's under their kind of ecosystem umbrella. And the only really disadvantage to this picture is that we don't have compatible transport between any of these bubbles. So we don't have the ability to send video from A to B, and we also don't have the ability to see, other boxes and make connections, which obviously you would need to be able to have the video work between them in order for that to matter. So that leaves us kind of with a situation where Pro AV presentations are kind of handled with one class of products. And if you're doing kind of live productions or you need to do seamless multi-camera switching and vision switching, you're going to use kind of a different class of products. You have to either decide what you're going to do, or you've got to live with multiple ecosystems. And those ecosystems require different network capabilities, different topologies, different services running on those networks. You oftentimes have to pick which network bandwidth you want. So if you want to do something that's more uncompressed or very lightly compressed, you would go with 10 gig. But if you are building for kind of a more common network that you see nowadays, or you're looking to handle more channels, you might be forced to pick a 1 gigabit system. And so, at the end of the day, you're forced to pick and lock in, right? And for manufacturers that have these ecosystems, there's obviously a real competitive advantage for that. But for the most part, you find a lot of manufacturers having to maintain multiple product lines as they want to take advantage of multiple standards. This complicates support, and also manufacturers are kind of at the basically. I don't want to say service, or they're basically at the mercy of a single supplier. If they're kind of picking one of those one of the more interoperable options out there. And at the bottom line is the whole industry is kind of continually to innovate on the sort of plumbing, on the sort of basics of AV over IP. So we find ourselves kind of competing on the last 5% or 2% of the system, instead of kind of coalescing around one option and innovating at higher layers. So what is it that we need? Is it really another standard that we need? And I'd like to, at this point, ask that you guys stop sending me this comic. I probably get this at least once a month. It's one of my favorite XKCD comics, where we have 14 standards, and we all recognize that we need something to cover every use case. So then we end up with 15 standards. But in this case, excuse me, water there. I have great news. We are actually talking today about IPMX, which is not a brand new standard. It's a proven standard that's been in development for quite a number of years now, kind of going on almost like a decade now, if you include SMPTE 2022. Um, really, IPMX is an open standard for AV over IP that builds on SMPTE 2110 and NMOS. And I'm going to go into detail on that. Um, when we started off, we kind of looked at what we needed in Pro AV, and we used our own experience, and we also had a lot of conversations with people at Infocom and at ISC, and with vendors that we went to visit and customers. And we kind of came down to this set of main criteria that we really focused on. When we started off, we sort of started off with SMPTE 2110 and NMOS as it was, and we found that while it offered the quality and the performance that people wanted, the cost of implementation and the cost of equipment was really stood out as kind of a barrier. So we looked at security is really important in Pro AV. Obviously, that's authentication and access and encryption, low cost operation. We learned that, we all love to run uncompressed signals, but what people really want is great quality and low latency on networks that they can afford to operate. And that means compressed and sometimes uncompressed video is important. We also see that the next two items here on this slide here kind of go together, but we see that software implementations are really important, especially as we bring cloud computing and more virtualized platforms into our workflows, making sure that whatever we came up with was going to be friendly to software implementation. We also learned, and this is in part, we learned this from the broadcast experience, that really the open discovery and registration, the API that kind of fronts the whole system, is as important as the transport side of it. And so that was a big goal, is making sure that the basic ability to just discover video sources and video receivers on the network and to be able to connect them together had to be open. The other thing we learned is not so much that we had to get rid of, PTP timing and, all that, but was that in Pro AV, we needed to actually introduce some flexibility in there. So there are times where you need very strict timing so that you can have extremely low latency and synchronized sources. But most often in Pro AV, you're dealing with asynchronous sources, and you really don't have the option to run an expensive master PTP clock. So we needed to have the timings and those kinds of things more well specified. And that's actually going to be an interesting topic in the next talk that is going to be after this one. And another thing that we learned is having open control mechanisms. That doesn't mean that what we're setting out to do is to create, the control layer so that we're going to take over, the entire ecosystem. But what it means is to provide the facilities that manufacturers and people that are building these software systems that manage these systems have the open control mechanisms so that they can communicate in the same way to the devices in an interoperable way, while still having plenty of room to innovate and create those applications at the higher level that actually enable this technology to work. And finally, another thing that we sort of came to on our own is that when we were looking at the market, the feedback we were getting was that AV over IP is one thing and then broadcast is another. But what we kind of came to understand is that we're all broadcasters now. We're all doing presentations now. We're all, we all have conference rooms, we all have digital signage, and we also all are making productions, and we're doing things interactively, and we're using video. It isn't like in reality there's really two worlds. The reality is that we're all using video in a lot of different ways. And so the technology that we wanted to finally end up with wasn't one that was unique only for just AV over IP. And then if you wanted to do productions, come over and use SMPTE 2110. We actually spent a lot of time thinking about how those two worlds interact with each other, and how we can make them really behave like one world. So when we kind of came up with IPMX, this is the basic set of highlights of the features that we we came around to. Um, we start with an established set of standards, 172110 and NMOS, which if you kind of take a look at those standards, you'll see that they're very composable. They're broken down into small pieces that work together, and they were really a perfect fit for what we were trying to do. Um, they already came with multicast and unicast support using UDP and RTP, which is technology that's very common in AV over IP and in Pro AV right now. Support for video is all the way down to, I don't know if it's like 2 pixels by 2 pixels, but it's, very small video to all the way up to 32K. And I apologize for the S in front of EDID here. That was a mistake, but we also wanted to support EDID and hot plug detect and the kinds of behaviors that you expect from baseband video connections that consumers are used to and people in Pro AV are used to. We settled on JPEG XS compression because of its performance with 4K 60 over a 1 gig internet or a 1 gig network connection. And we also wanted to allow for uncompressed video as well for situations that required it. We're using AES67 for audio. Excuse me, let me drink some water here. We're using AES67 for audio, and we're adding profiles and definitions for the common formats that you'll find, especially over HDMI and also in Pro Audio as well. And as I mentioned, PTP timing in general, we really are spending a lot of time on this topic. We're making PTP optional for point-to-point connections, and we're providing some guidelines to how to make PTP easier to implement in these systems. And we're explicitly supporting asynchronous and synchronous sources. So not just SDI type sources, but also HDMI type sources where the clocks are independent from each other. We had settled on the NMOS API, which is popular in broadcast and provides everything that we need in Pro AV for discovery and registration, and also provides an excellent framework for us to build upon for adding the different control layers that we need in Pro AV. For security, we're working with NMOS to develop guidelines for interoperable security and defining what an IPMX device has to support in order to support security. And I include HDCP 2.3 in this as well, which is another thing that we're working on. Having, well thought through, approved, clear guidelines for implementing HDCP and IPMX is a central goal of ours. And control. We also wanted to enable interoperable USB and KVM support. Because that's obviously a central use case for AV over IP, and having devices that can extend USB and also other things like serial and GPIO was an important addition or consideration. This is a view of the what's called the JTNM roadmap, and now you notice that IPMX is not on this page here. It's a little bit of kind of in the weeds detail of why that is, but suffice it to say, AIMS is working with a number of organizations, and we are really the ones that are kind of driving that IPMX brand name and also, helping promote it. JTNM is the group that's kind of on the say like a lower level that coordinates use cases and coordinates the actual activities that happen. So at their level, they're really looking at Pro AV as a broad term. So that's why we don't use IPMX on the slide deck. But this is the this is a kind of a view of the roadmap. If you want to see the official version, you can go to the JTNM website, and I can provide you a link to that in chat later. But this is basically the roadmap that we are working on as we're working on it. You'll see that in progress here, we have a lot of the items that I just talked about. In phase 1 here, we have some additional behaviors and APIs that we're adding to the system to enable some things like ARC and CEC support, more like pass-through, not so much like re-implementing CEC and over IP. We also, another important one here is in phase 1 is forward error correction, which is really critical for AV over IP, and that's something that we're planning to work on very soon. I mentioned the Pro Audio formats, and I also mentioned HDCP and content encryption there. Kind of further out, you can see that's where we start to get into USB. That's where we start to look at getting some training programs going. I also wanted to just quickly mention that that WAN and internet compression, internet level compression for cloud, basically traversing into the cloud, is also part of the picture of IPMX as well, though that's kind of further out. Now, for those of you that are familiar with the OSI stack or networking stack, you're going to have to unfocus your eyes a little bit here. In fact, I took the word stack out of here because I didn't want to confuse many people. But when I started this presentation, I was really thinking about, how to communicate how IPMX is put together. And I thought that the stack diagram kind of works. But if you're familiar with a stack diagram, you might be looking for TCP and UDP in here somewhere. And that's not in there in this level of detail because I wanted to make it readable on a single slide. But you notice kind of going from the bottom up, the physical layer, we don't really define the network speed for IPMX. So we did have a goal of being able to support UHD video on a 1 gig connection, but that doesn't mean that IPMX only works on a 1 gig connection. So we do anticipate and support devices that support higher bandwidth connections. The protocols that we use that are, the rest of the stack is built on are the same protocols that the rest of the internet uses for this type of work. RTP for real-time protocols and PTP for timing. And then for asynchronous control traffic, we use HTTP WebSockets and MQTT. If you look at the darker blue section here, this is where SMPTE 2110 really resides. And there are some things that we're adding into that set of standards in the organization called the Video Services Forum, or VSF. That's where we're working on the additional standards for synchronization and timing. And that's also where we'll be working on forward error correction. Ancillary data is already more or less defined in there, although there is some work for us to support closed captioning. And as you might know, closed captioning with HDMI is not really a thing. So there's a little bit of work we need to do there. Asynchronous control traffic on the right here, a lot of this work is future work, although right now within an organization called Advanced Media Workflow Association, or AMWA, that's where we're working on EDID right now, and we'll be adding more work as we go along there as well. But this is where we're defining how dynamic connections work and that sort of thing. And in fact, if you look up here in this orange section, this is where NMOS kind of resides, and you'll see that's where this dynamic EDID connection is. This is where all the APIs are for IPMX. So registration and discovery. This is where you can find the devices on the network using either MDNS or I forget. It works in registration mode or P2P mode, and I forget which technology is in use with either. But perhaps somebody can tell me or can share that after I'm done here. But and then ISO 5 is used for subscription. This is actually how you make your connection between two devices using ISO 5. And then some of the other control protocols here, like device control, this is where you can set up direct connections between devices and send commands across to manipulate them. That's part of the standard right now, and we're actually doing even more work on that in AMWA today. So at the top layer here, this is where the innovation happens. This is where the implementations of the software happen. One thing you notice here, this RDS service, that's registration discovery service. That's a component, an implemented component of NMOS that a manufacturer might provide. That is what the registration of the NMOS devices gets put into. So that's what you would go to see what's on the network when you have a larger system that uses a registry. And you'll see also that we use OAuth 2 for authentication as part of the standard, and that's an example up here. But then also this is where your favorite manufacturer's Pro AV controller would be, where you do device management and where you'd actually name things and use the software as you would today. At the end of the day, what our hope is with a standard that is that has the API and the transport that is enables interoperability for customers, we see an environment that not only is lower cost, but also more, I think almost more importantly, the ability to pick the best product for the specific need that you have. And that's really, we believe, or what we've seen is that that's kind of what's driving complication right now. You have to, sort of pick the best, overall manufacturer for everything you might do in the future. As we all know, sometimes that doesn't work, or people have different opinions about what the best is, and that's causing a lot of complication. So now, by making that lower transport and an API um, interoperable, we're giving people the freedom to pick the best product for the need without creating a complicated situation for them. And in the end, making video work like a utility again, something that just works. And for manufacturers, for some, they might find this, to be a little unsettling, but we really believe that once the industry can kind of move past innovating on the plumbing, that we can get to really a lot more creative applications for video and a lot more creative applications for Pro AV, and finding expanded markets. So where you might be more thinking about, how am I going to enable a lecturer to stand in front of a room and put their video up, but now getting into more of the production and getting into more of that live interaction, and broadening out the possibilities for the products that you make, by making the whole world of video accessible to everybody. And in the end, we all everybody is looking for happy customers, right? So I just wanted to end on one more slide here that just kind of highlights some of the organizations involved that I mentioned a little bit. AMWA, as I mentioned, is the control plane specifications and API, and VSF is Video Services Forum, and they're doing more of the transport and real-time specifications. Those are the two groups that are kind of doing the additional work on IPMX. And AIMS, the organization putting this event on, is in charge of advocacy and the marketing side of things. And all of the other organizations you see listed there have contributed standards over the years that are a big part of IPMX and its future success. So we wanted to recognize those guys as well. So that's all I had in my short presentation here, and I'd be happy to take any questions or comments that anybody has.